Hello and welcome to the first episode of the De-mystifying AI series from ARBI.CITY, in which we give you a 5-minute primer on neural networks, the technology behind the latest advances in the field of artificial intelligence. Our series is designed for non-technical professionals, and when we mention technical concepts, we try to provide explanations or references to other episodes where the term is defined. Today we will discuss what an artificial neural network is, how it learns, and how it differs from other machine learning techniques. An artificial neural network is a computational model inspired by the human brain, designed to recognize patterns by processing data through interconnected layers of many simple elements called neurons. For illustration purposes, here is a simple neural net showing an input layer on the left, where the data comes in, two middle layers that process the data, and a layer on the right containing the output. It actually takes only a few lines of computer code to create the structure of this simple network. So how does a neural network learn to recognize patterns and make accurate classifications, predictions, or recommendations? In traditional supervised learning methods, training the neural network involves providing it with data that was labeled with the correct answers, and then getting the network to generalize from those examples. This learning process, once properly completed, results in the numerical values for each neuron getting calibrated using advanced mathematical techniques to produce appropriate outputs. In this simplified example of a house price prediction model, in which house prices are solely a function of house size, the model has two examples of house sizes with corresponding prices, and the function learned by the model is represented by the upward sloping line. Using this learned function, the model can now attempt to predict prices for other houses based on their size. In more modern unsupervised learning methods, the neural network is not given labeled examples, but rather is tasked with identifying relevant features and patterns in the data for itself. For instance, an AI model may learn to associate certain words with other words that might have a related meaning. For example, it might associate words like cat or dog with pet, and for any given word may then be able to give you some other closely related words. While this simplified example may be easy to follow, the actual patterns created by unsupervised learning methods are often so complex as to be completely indecipherable, even to the data scientists who initiated the training. As another example, a neural network can be fed millions of books and learn the relations among them along thousands of different dimensions. Users can then receive book recommendations based on the patterns identified by the neural network. But the basis of the recommendation may not be easily explainable in human terms. This, of course, may be fine for book recommendations, but not fine in other contexts, where certainty and explainability is essential. Neural networks can be contrasted with decision trees, which are usually more straightforward and explainable rule-based algorithms. In a simple example like the animal classification scheme shown here, the reasoning is easy for anyone to follow. Decision trees and similar algorithms in machine learning do get much more sophisticated, but they are still a type of supervised learning based on human-specified criteria that follow an if this, then that structure. They are less powerful than sophisticated neural networks, but they generate more predictable and explainable outputs. To summarize, decision tree algorithms follow a clear path and have high explainability and predictability. However, they tend to be simpler systems with limited versatility compared to neural networks. When neural networks undergo supervised learning, they can extrapolate from specific examples, and the outputs are generally explainable based on the training data and other human-specified parameters. Although these systems can be useful in a wide variety of contexts, each system is still only able to perform a very specific task it was trained for. By contrast, unsupervised learning involves much more complex patterns derived from vast amounts of data that would be impractical for a human to decipher. The latest advances in unsupervised learning are behind AI systems like large language models, which appear to have an almost magical capability to speak our language, and which we will cover in our next episode. If you enjoyed this episode, please like, share, and subscribe, and we hope to see you again soon.